Hello, good day everyone. Welcome back. In the previous discussion, we talked about the basic things we need to take note of when working with data, and we also talked about the some ethical issues that needs to be taken into account, and also the stages that will likely be involved when working with data. And we talked about some hands-on activity will be followed after the basic um, theoretical discussion. So in this next session, we will look at how to apply some of the techniques of processing or working with data, some form of EDA, exploratory data analysis. These are the data sets that we have collected. We have the link here for relevant some examples and links to relevant data sets. Other source of data set that can be used include the UCI, Kaggle, and there are lots of other sources as well. You will see some examples with the link to some of these sources. And then after building the um, after identifying the source of the data, collecting the data, processing the data, then we need to build relevant models and train the models using the data that we have transformed. And then it's important to know what are the different stages, what are the tools that will be required at the stage you are currently working with. So some of the main issues, maybe we have the three basic steps we talk about. We talk about the data acquisition and data storage. So it's good to know how do we acquire the data, how do we store the data, and then how do we process the data, pre-processing and transformation. So cleaning the data, transforming the data in the form that can be usable by the model we intend to work with, then performing some form of exploratory data analysis on the data. So knowing what set of tools and techniques to apply will help, and then building the models. What sort of models do we need to use? Which models are suitable for the data we are working with? And then taking into account the different arrays of models that you can work with. So knowing the different models, how they work, how they apply in your context, and also what relevant packages or frameworks you can utilize to help with that. Then what sort of evaluation that you will conduct to ensure that the model you have built is actually effective. So this session will look at this example, and this example here is basically on Google Colab, which have this cloud-based Jupyter notebook that can be used by anyone with account with Google, and then try to run some models. And also you have the option of probably using some of the free GPUs and TPUs Google provides. So it's with what exploring this option. So Google Jupyter Notebook is basically an environment that enables us to write, take note about what we are working on, and then also run a computer code which is based on Python for this example. So in this example, we'll be using both synthetic and real data. In our discussion earlier, we talked about the examples will be based on synthetic data and real data set. So the synthetic data is basically the data we collect. It's a toy data. It doesn't really exist. We create the data for the sake of illustration or making some point. And the real data is the data that has actually been collected under certain real case scenario, also data that has been collected over time by an individual or organization. So we will use some data set from both sources in this example. And then other environments that you can play around with to run your code, in addition to the Google Colab. Kaggle offers Jupyter Notebook as well. Once you create an account, you can access that environment and utilize it in your work. IBM has similar environment, and there are other environments and IDEs that you can use to run your Python code. But for these examples and this session, we'll be using Google Colab, and all the dataset and other relevant resources will be shared. The link will be provided under the video description. And here is also the link for the Kaggle and the UCI repository. This Jupyter Notebook will be shared as well, so you can access the link and then explore the different data sets they have. So for this exploratory data analysis, we first require some packages. So here we are loading the packages that have already been developed by others, and most of these packages we don't need to install them if we are using the Google Colab, because it's already available. You just need to know how to call these packages. And in some cases, some packages, if not available, you need to install those packages. And if you are using different IDE or running on your local machine, then you need to install these packages on your machine to be able to access and utilize the packages. But in our case, because we are using the Google cloud-based environment, so all these packages are already installed, so we just need to know how to call the packages and utilize them. Here we are creating a toy data. So this is the data about customers rating of an online store. So we create the data with 4 variables. We have the user ID, the age of the user, the amount, and also the rating each individual user assigned to their experience with the store. So we create the data, and then we are using the pandas function. Here we are using the alias, which is the PD. Here, when calling this function, we are using this function pandas but because the name is a bit lengthy, so we don't want to use the lengthy name, we provide some abbreviation that we would like to use to refer to that, such as a nickname. You can view this as a nickname to the package. So rather than type in pandas each time we want to use something from the toolbox, then we just need to use this PD. So under this toolbox, this pandas enable us to convert. So we have this function which is the data frame, then it will accept the data that we have created here. So then this will be the input to this function from this data frame. So we convert our data into sort of Excel format. So you can view these pandas as Excel for Python. If you want to process your data, you want to arrange your data into more readable format, then you can use the pandas package to help you with that. There are lots of packages, functions under this package that you can explore. So here we have our data converted in this table with the 4 columns or variables, and then the different users, about 10 of those users that we have. So now that we have our data in this format, we don't need to do any further pre-processing because the data is basically small and all the variables, the values for the variables are intact. So here we are computing the basic statistical measures. Here we are computing the mean of the numerical values, here the mean of the age, then the median of the amount, and also the standard deviation in the ratings, how often, how the customers' ratings divide. So here we are printing the actual values. We have also here we have the mean for the age, which is around 30 years of age, and then we have the median purchase amount, which is about 115. Then we have the standard deviation of the review, which is about 1.4 approximately. Here we are providing a basic form of visualization. So we want to visualize 3 different columns using different visualization techniques. Here we are using histogram to visualize the distribution of ages. So we have the ages from 25 up to 45. So here is the distribution of the ages. Then we have the distribution of the amount. We are using box plot, which basically gives us all the summary we need to know about the variables. Here we have the mean value, we have the maximum value, here we have the median, and then we have the whether there are some outliers. In this case, we don't have any outlier, and then we can access the 25th percentile, the 50th percentile, and also the 75th percentile as well. So all the relevant statistical information we need about a particular variable, the box plot can give us this information. And then we use the ratings. We use this to visualize the ratings given by each individual customer for each item. So here we have the customer's ID. Remember, we have the customer's ID in numerical form. Here we have 11, 21, 31 up to 111. So then for this customer, this is the rating the customer provided, and for this customer we have this rating. So these are all the different. So this is a basic illustration of what to do with the data, just to visualize and understand how the data, what are the distribution of the different variables we have in the data. Then we can perform some correlation analysis. So here is an example of a basic correlation matrix involving all the numerical values we have in the data. So correlation is basically telling us the relationship between items. If you pick any 2 items, you can ask what is the relationship between these items, how are they related. So there is positive and negative correlation. Positive correlation is basically these 2 items. As you increase the value of one item, the value of the other item also increases. So they have this sort of pairwise relationship that is positive. They tend to increase together or they decrease together. This is positive correlation. Negative correlation is when you increase the value of one variable, then the value of the other variable will decrease it. So they have negative correlation. Increasing the other variable will have negative impact on the other variable in the sense that it will decrease that variable in value. Or increasing the other variable then will lead to decreasing the other value. Or the values or the variables can have no any correlation. The impact of one variable doesn't have any direct impact on the other variable. So this is there is no correlation. So when you pick any 2 items through correlation analysis, you need to ask how are they related and what is the nature, in which direction the relationship is. Is it negative or is it positive? Or there is no any negative correlation. So this is essential when making decision on which variables to include in your analysis moving forward, right? If the variables the fact that you have all the variables together that will negatively affect each other or positively affect each other, how will that impact the entire analysis? What is the essence? Then you need to debate what action to take, why it is required, and justify whatever action you take on that basis. So here we are using the heat map that summarizes what we have. So here at the very top we have this somehow red or orange coloration with 1, which is basically the positive correlation, and we have this blue, which is the negative correlation. So depending on the magnitude or the intensity of the color, then it tells us. So all this here we can see these are variables that are negatively correlated. So here, for instance, the user ID is positively correlated to itself, because always correlation of an item to itself is always 1. So the diagonal here is always going to be 1. But here we can see there is high degree of correlation between the age and the user ID, but here it is not telling us any much information, because the user ID is just numbers that we assign randomly, and because they are somehow very close to the sort of numbers, the integers we expect for age, so it doesn't say much that will be of use to us. But what happens here, we can see some negative correlation between the amount the user spent and the ratings they provided, right? Perhaps for users that are spending too much have negative experience, or for those that are spending less have more positive experience. So you need to explore and dig further into the data to see why is this sort of correlation happening. Or it might be there is no any much correlation between, so in that case the value will be just 0. So here we have, so this is the synthetic data we'll use. So for the actual real data, we'll be using data from a data set about foodstuff that is available on our Google Colab. So this is the directory. We have already mounted this Google Drive where the data is located. So we change into this directory using this command, and then we load the packages. We have already loaded these packages earlier, so we don't need to repeat that again, but that will not cause any harm when we run the cell again. So the data we'll be using here is from the National Bureau of Statistics, which is basically the body under the Nigerian government that track and collect and curate relevant data set across the nation. And the example here, the data set we picked here is from this NBS site. It's really made available for download. So we downloaded the data from this site. It's about the foodstuff price watch, and then we process somehow, because the data has already been processed and presented in these nice tables, but we just transform it to a different format that will make it easier for us to work with for this analysis. But we didn't change in terms of the content or introduce anything. All the information is basically based on information that was provided by this body. So we just transform the data to make it more suitable for this particular use case. So this is the location of the data and the name of the file that we have transformed. So the data is a collection of the food items that have been collected from different states of the federation, and then the respective prices for individual items across different months and years from July 2021 up to April 2024. So the collection is not on monthly basis, but there are some gaps in between the collections. So when you have for July, June, then the next collection will be after some months, then before you have additional data available. So here we are using to check the data if there is any missing value. So missing value is whether for each of the variables or for each of the columns we have item that is missing. For instance, if we're supposed to have food item here and the value is missing, this heat map will somehow tell us what is actually happening with the variable, whether we have some missing values in the data. So for this example here, now that we have loaded the data, we have checked the value, and then here we can check whether we have any missing value. So for this, we don't have any missing value. Had it been we have missing value in any of these columns, these we'll see some white or yellow dot or red dot depending on how we set the values or the variable here in the function that we use from Cbond. So here, because we don't have any missing value in any of the columns in the data, so that is why we have this uniform purple color. Had it been we have any missing value in any of this, then we have some traces or some dot of yellow or white dots in this visualization. So we'll see in future sessions what do we do with any missing value, how do we handle missing value, how can we tackle any incidents of missing values, and also other ways to check for missing values in the data. Because here we don't have any missing value, then we are free to move forward. So here we are performing a basic form of visualization. So we are using this bar plot just to illustrate how to visualize individual items as x-axis and the prices of each item as y-axis. And then here, because we have too many items in the data we are working with, so we just focus on a few data points. Here we can reduce it to just 15 items here, meaning from the beginning up to the 15 items. Then here it will give us only the first 15 items in the data that we have. So here we can see more visibly, we can see all the food items. But if we can use the whole of the data, but that will make the x-axis a bit muddy, not that very visible for the eye. So we have to, so then maybe we can split this into multiple plots so that we can easily read what the values are for each. Here, because we have the collection for different months, so that is why we also have these different values with obvious deviation in the values based on the example we have shown in the first plot. Right. So here is the same data that was loaded earlier, because the file earlier had same common name with the file we used earlier, but it's the same file basically. So here in the first example, using the synthetic data, if you remember, we compute some of the statistical measures manually and print the values here. Here, we calculated the statistical measures here manually. So we assign, we define the variable we want, and then we use the .mean function to print out the values here. But with pandas that we talked about earlier, we can access some composite functions that will enable us to compute other statistical measures as well. Common example is to the describe function, so which basically takes the name of the file and then using the .describe to give us relevant statistical measures for the data we are working with. So in this, it will identify all the columns that have numerical values in the data, and then it will give us this sort of statistics about the count for each variable, the mean value, the standard deviation, the minimum value, the 25th percentile, the 50th percentile, the 75th percentile, and also the maximum value. So, for instance, the lowest priced column here, we have a total of 28, which tallies with the total number of data we have, meaning had it been we have any missing value under this column, the count here will be less than the actual total size of the data of 258 here. And then here is the mean value, which is around 954 approximately naira. And then here the standard deviation, we can see we have very high deviation here. And then we have the minimum value, which is 60 naira, and then we have the maximum value, which is about 3,800. This obviously tells you that there is high inflation since 2021 to date, which is April 2024. Which the reality is that we have this currently we are witnessing high inflation at the moment. Right. So this is another way of summarizing what the data is, and then you can pick whatever value or whatever measure is of interest to explain, and also elaborate on the explanation based on the outcome you realize. We can have a more advanced visualization of the data. So here we are using in the example here. So we are using this plotly graph .graph package, which is this one. So we assign the nickname or alias of this package as GO, which is Go. Normally, this is the graph object. This is the notation. This can be any value that you would wish to use, but generally the convention is used by experts in the area. They generally use this GO for consistency and also to be in line with the convention. Yeah, so here we are using that package, which is basically, you can see here we are initializing that, and then here we specify what sort of items we need to visualize, and here we are visualizing the individual food items, and then the price of the item. Then we want to show the actual month, the price of the item, and also the actual location where the food item was collected. So here we have all the data elements, which in this case the food items, and then visualizing that from July 2021 up to April 2024. So the first line plot here is about frozen chicken. So this frozen chicken was in June 2022 was about 1,505 naira, and the lowest the state with the lowest value was Gombe. And then we have the same for July, but then in April 2023, then we have some changes in the value, and then the frozen chicken was around 3,800, and the state that was reported here is Ondo. Then we have up to the last collection month here, which is April 2022. So then the second one here is for the next food item. In this case is beef, which is boneless, and then we have the price and also the stage in which it was collected. And here we have catfish, dried. So we have all the food items. When you hover over the individual lines, you will see these three information: the item name, the price that was reported, and also the actual state that the food item was reported. So this is just one form of visualization. As the name suggests, exploratory data analysis. You are exploring the data, so there is no right or wrong way of saying, okay, your exploration is you shouldn't do this or you shouldn't do that. It depends on what your needs are. What are you interested in exploring? What are you really interested in presenting? Who are your audience? What do you want to do with it? So the path you have taken or the approach you have taken, as long as it is making sense to the use case you are using, then it's something that you can keep exploring. Hence the name exploratory data analysis, to help you understand the data, to help others understand what the data is. So you can see there are lots of rooms for maneuver in this case. What you decide to work with, how you want to present your data, and what you can do with the insight you are generating from the data. And there are lots of different tools that you can apply. Remember, in the